Yes, to the viewers, my names are Matthews Nondo. Last time I did last time I did network analysis with reference to the probability of project completion time. Today, we want to learn how to crash a project. And crashing of a project is a deliberate reduction in the planned duration of the project by using extra resources. When you use extra resources, then you shorten the activity duration. Eventually, it is going to reduce the planned duration of the project. Now, in crashing of a project, we have some terminologies which we'll be using, and eventually we will apply those concepts to crash a project. The first terminology here is normal time. The normal time is the planned duration of the activity based on the resources which are available. Then we have what is known as crash time. Crash time is the shortest time taken for the completion of the activity if extra resources are used for the completion. The extra resources which are involved in crashing time is we can use overtime premium, that is extra cost. We can hire machines, we can engage more workers, and therefore the activity duration will be shortened. This time is known as crash time. Then we have the normal, the normal cost. This is the cost which is associated with the normal time. That is the cost which is planned for the completion of an activity. Then we have what is known as crash cost. This is the cost which is associated with the crashing of an activity. Then now we have the steps for crashing of a project. The first step for crashing of a project is construction of network and determining the critical paths. So the first step is to construct network and determine the critical path. So that is the first step of crashing, that is construct network diagram, determine the critical path and the total project duration. Then step number 2 of crashing is calculate the cost slope for each activity in the project. Cost slope is defined as the average cost of shortening an activity duration, and it is calculated as cost slope is equal to crash cost minus normal cost all over normal time minus crash time. So cost slope is equal to crash cost minus normal cost all over normal time minus crash time. It is obvious that crash cost is always greater than the normal cost because of the extra resources which are used. Then normal time is always longer than the crash time because the crash time is shorter due to the extra resources which are used for the completion, as I had stated earlier. Now, step number 3 of crashing of a project. Identify the activity with the minimum cost slope, and it must be along the critical path. So that is, identify the activity with the minimum cost slope, and it must be along the critical path, which must be along the critical path. Why do we have to identify the activity with the minimum cost slope? We want to crash the project when we have economics in mind. It must be economical to crash the project, and therefore we must go for the activity which has got the minimum cost slope. Then step number 4, calculate the total normal cost of the project. The total normal cost of the project is the total direct cost for all the activities in the project. We have direct cost and we have indirect cost. The indirect cost, these are cost of administration and other expenses of overheads. But here we only go for the direct cost for each activity. That is the cost which is incurred in performance or completion of an activity. So step number 4 is obtain the total direct cost for the activities. That is step number 5. Now step number 4. Step number 5 is reduce the planned activity duration. Reduce the planned activity duration based on the minimum cost slope, which has been previously what had been obtained from the critical path. So reduce the planned duration of the activity based on the minimum cost slope. Then reduce the planned duration of the activity based on the minimum cost slope. Now, when we crash the activity or the project, we'll be guided by the time which is available for the crashing of each activity, which I'm going to show you as we start now crashing the project. Now, this process can be repeated. This process of reducing the planned duration of the activity can be repeated based on the minimum time for the crashing. The minimum time for the crashing means you can crash the project till, if you continue crashing, you will find that the total duration of the project is not changing. when the total duration of the project is not changing, then another critical path or more than one critical path will be developed, and therefore you stop crashing that project, and therefore that project shall have been crashed to the minimum duration. Now, let me go through these steps. That is number 6 is the process can be repeated. That is step process. The process of crashing. The process of crashing the activities can be repeated till there will not be any reduction in the duration of the project. So these are basically the steps for crashing of the project. Now, as we will be calculating the cost slope for each activity, the cost slope will be arranged in ascending order, such that you crash their activities with the minimum cost slope, then you crash the next so long as it is existing along the critical path. So the first step is to construct network diagram, then determine the critical path. I'm going to use this example to draw network and show you how to crash a project. Table 1 shows a project which comprises of activities whose duration are in days and cost in Kenya shillings, thousands. So, activity 1 to 2, we are going to use the normal duration, the normal time in the construction of network. So, that is 1 to 2. This is now the network diagram from 1 to 2, 1 to 2, 2 to 3, 2 to 3, this one, 2 to 4, that is 2 to 4, then 3 to 4, 3 to 4, then 3 to 5, 3 to 5, then 3 to 6, 3 to 6, then 4 to 5, 4 to 5, then 5 to 6. So the next thing is to introduce the normal time in the network. That is 1 to 2 takes 10 days. 10 days. Then 2 to 3, 2 to 3 takes 9 days. 2 to 4, 7 days. 2 to 4, 7 days. 3 to 4, 3 to 4, 3 to 4 is here. 3 to 4 is 6 days. Then 3 to 5. 3 to 5. 3 to 5 is 9 days. That is 3 to 5. Then 4 to 5. 4 to 5 is 6 days. Then 3 to 6. 3 to 6 is 10 days. 10 days. Then 10 days. Then 5 to 6. 5 to 6 is 7 days. We are using the normal time, normal duration. So we want to determine the critical path and the duration of the project. 0 plus 10, that is 10. 10 plus 9, that is 19. And this path and this path, 10 plus 7, that is 17. 19 plus 6, that is 20, 25, and that is the maximum duration for that. Then 19 plus 9 is 20, 28. 25 plus 6 is 30, 31. Then 19 plus 10 is 29, and then this one is the longest, that is 30 what? 38. The duration of the project is 38 days. 38 minus 7, that is 31. Then that is 31 minus 6 is 25. Then this is 25. It is approached by this part, and this. This is 28. This gives us 31 minus 9 is 22. Then 25 minus 6 is 19, is the minimum. 19 minus 10 is 9. 19 minus 9 is 10, and this one gives us 25 minus 7 is 18. So this is the one we are going to take. This is 19 minus 9, which is 10. Critical path is highlighted by this. We highlight the critical path. So the critical path is 1 to 2. Activity 1 to 2, then 2 to 3, this one here, then 3 to 4, this one here, then 4 to 5, then 5 to 6. The duration of the activity, we have said, duration is 38 days. So this is the longest path. 6 plus 6, that is giving us 12, while this path is only 9. So the longest path is this, which is highlighted. And these ones are the activities we are going to crush, because we had said earlier that we crush only activities which are existing along the critical path. Now, the next thing, which after drawing that, I want to know the activities to be crushed. And for me to know the activities to be crushed, I must calculate the cost slope for each activity. The cost slope for each activity in the project. Activity 1 to 2, coast slope is, that is crash cost minus the normal cost all over normal time. Normal time is 9, sorry, normal time is 10 for activity. Normal time is 10 minus the normal what? Minus crash time. Crash time, normal time is 10. Crash time is 8. So that means activity 1 to 2 has got 2 days which are available for crashing. So this one gives us 120 divided by 120 minus 6 is 60. 6 divided by 2 is what? 30. And this one is Kenya shillings 30 per day. But these ones are existing in what? Thousands. Kenya shillings, which we are going to include that cost, including that 1,000, the thousands, when we are adding. So these ones are existing in thousands. Then activity, the next activity is 2 to 3. 2 to 3. 2 to 3 is, the cost to slope is 150 minus 75 all over 150 minus 75 all over 9 minus 6. 9 minus 6, that comes to 150, that is 75 divided by 3, that is Kenya shillings 25 per day. Then we move to activity 2 to 4. Activity 2 to 4. Activity 2 to 4. That is, the cost slope is 150 minus 90 all over 7 minus 4. That is 150 minus over 7 minus 4, 150 minus 90. That gives us, this is what? This is 60. 60 divided by 3, that is Kenya shillings 20 per day. Then activity, that is activity 2 to 4. Activity 3 to 4. The cost slope is, the cost slope activity 3 to 4. The cost slope is 140. 140 minus 100 divided by 6 minus 5. That means there is 1 day available for crushing of activity 3 to 4. This one gives us, this is 40 Kenya shillings 40 per day, but they are existing in thousands. So we are going to, that is 3 to 4, then 3 to 5. 3 to 5, the cost slope is equal to 3 to 5, the cost slope is 80 minus 50 divided by 9 minus 7, which is Kenya shillings. This is 30, then this is 15 Kenya shillings per day. Then we move to 3 to 6. 3 to 6, the coast slope is equal to 3 to 6, the coast slope is 70 minus 70 minus, that is 3 to 5, 70 minus 70 minus 40, 70 minus 40 divided by 6, so it is 8. This is 10 minus what? 10 minus 8. So that is 70 minus 40 divided by 10 minus 8. That is 50, this is what? This is 30 and this is 2. This is Kenya shillings what? 15 per day, and this is 15,000. Then we go to 4 to 5. 4 to 5. 4 to 5. The coast slope. 4 to 5. That is 70 minus 50 all over minus 6 minus 4. That coast slope is, this is 20, then divided by 2, which is 10. Kenya shillings 10 per day, but that is existing in what? In thousands. Then we have 4 to 5, we have 5 to 6. 5 to 6, the coast slope is 5 to 6 is 110 minus 70 over 7 minus 5, which is 40. This is 110 divided minus 70, that is 40 all over 2, which is Kenya shillings 20 per day. These are the coast slopes for all the activities in the project. Now, we want to see which activity we are to crash. And all the activities which are existing along the critical path are here. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Which one has got the minimum coast slope? Which one has got the minimum coast slope? So, and it must be along the critical path 1 to 2. 1 to 2 has got a coast slope of 30, and 2 to 3 has got a coast slope of 25. 3 to 4 has got a coast slope of 40. Then 4 to 5 has got a coast slope of 10. And 5 to 6 has got a coast slope of 20. So what we are going to do is to crash the activity which is 4 to 5, which has got the minimum cost slope. So 4 to 5 has got the minimum cost slope. So the cost slope is 10 per day. But you can see from activity 4 to 5, there are 2 days which are available for crashing. That is 6 minus 4. That is the crash, normal time minus crash time that is 2 days which are available. So what we are going to do is we are going to add that cost slope for the direct cost. The direct cost of the project is we add the normal cost. That is the first thing, normal cost, which we could have done. That is the total direct or normal cost. So when we add the total normal or the direct cost of the project, that is I think I can now grab on this. Then the total direct cost of the project is 60 plus 75 plus 90 plus 100 plus 50 plus 40 plus 50 plus 70. This gives us a total cost of 535. This gives us a total of 535. This is 60 plus. So this gives us a total cost, total direct cost is equal to Kenya shillings 535. They are existing in thousands. From there, the equation. Now, we want crash activity 4 to 5. You want crash activity 4 to 5. So, but there are 2 days which are available for crashing of this activity. So the 2 days which are available, that is the crash time for that activity minus the normal time. Sorry, the crash time minus the normal time minus crash time gives us 2 days available for that. So we reduce this, that is the reduction of the duration of the project. So when it is reduced to 2, it's reduced by 2, then it becomes 4 days. 6 minus 2 days, that is 4 days. Then the next thing is we have to add. So crashing per day was 10,000. So plus 10,000. But that was per day. But there are 2 days which are available for crashing of that activity. So it becomes 20,000. 20,000 plus this becomes 555,000. That is when activity 4 to 5 has been crashed. Because we have crashed it, we draw another network. Another network is to be drawn because originally it was having 6 days before crashing. Now it has been crashed to 4 days. Let us see what happens here. Now we draw another network diagram. So 9, that is 19. 19 plus 6, that is 25. It remains 25. 25. 25 plus 4 is 29. So this one becomes 29. 29 plus 7 is 36. Nine plus 7 is 36. 36 minus 7. 36 minus 7 is 29. 29 minus 4 is 25. So 25 minus 6, that is 19. So the project has been crashed to 36 days at a total cost of 555,000. Then we check on the next activity, which is to be crushed, and that one must be also having a minimum cost slope. That is now step number 2 for crushing. We have crushed it once. We are going to crush it the second time. Now, when we check the activities which are existing along the critical path, there is activity 5 to 6. There is activity 5 to 6, and 5 to 6, according to what we have seen, activity 5 to 6 has got a cost slope of activity 5 to 6 has got a cost slope of 15. Activity 5 to 6, cost slope, that is 110 minus 70 all over 7 minus 5. 110, that is 40 all over 2, which is 20. So activity 5 to 6 has got a cost slope of 5 to 6, cost slope of 20 Kenya shillings, 20 Kenya shillings per day. So we are going to crush activity 5 to 6. 5 to 6, and how many days are available? There are 2 days which are available for activity 5 to 6. So we crush this, it becomes now 7 minus 2, because there are 2 days which are available. It becomes 7 minus that 5 days. Then 5 days at a total cost of, this is the cost after crushing the first stage. The second stage now, because it is 20 days, now it is 20, and 20 cost slope, 20,000 shillings per day. Then we multiply by 2 days, because there are 2 days which are available for crushing of that activity. So that is 555,000 plus 40,000, that is 40,000. It becomes 595 Kenya shillings, 595,000 Kenya shillings. But we have not drawn the network, because the network here, it was 7. Now we draw another network, that is 4 plus, that is 29, 29 plus 5, 29 plus 5 is 30 what? 34. 34 minus 5 is what? 34 minus 5 is still maintained. It is still maintained. It is 29. So the project has been crashed to a total of 34 days. The project has been crashed to a total of 34 days. Crashed to 34 days at a cost of 595,000. Then step number 3, activity. Let us check activity which is existing along the critical path, but it has got minimum cost slope, because the cost slopes are arranged according to this. We crash according to the ascending order. So the next activity which is to be crashed is activity 2 to 3. Activity 2 to 3. Activity 2 to 3. Activity 2 to 3. And activity 2 to 3 has got 3 days which are available. 2 to 3 has got 3 days which are available. That is 9 minus 6, which is 3 days. Then the cost slope is 25. The cost slope we had calculated is 25. Cost slope is 25 Kenya shillings per day. So activity 2 to 3 is 2 to 3. So there are 3 days which are available, for crushing. So we reduce this by 3 days. What is left is 6. 9 minus 3, that is 6. Then we draw another network. But before we draw that, we know that this cost is going to be added. This cost is going to be added. So that is plus what we had crushed, the total crushing cost, plus, that is, the cost slope is 25,000 times 3 days which are available for crushing. And that is, we add now 75,000 to this. When we add 75,000 to this, to the crush, the other cost, we get a total of Kenya shillings, that is 595,000 plus 75,000 brings 670,000 Kenya shillings. That is the cost which is incurred after the activity 2 to 3 is crushed by 3 days. So this is, you draw another network, that is 10 plus 6 is now 16. 16 plus 6 is now 22. 22 plus 4 is 26. 26 plus 5 is 31. 26 plus 5 is 31. This is 31. Backward pass, 31 minus 5 is 21 minus 5 is 22. 26. 26 minus 4 is 22. 22 minus 6 is 16. So the project has been crushed to 31 days at a total cost of 670,000 Kenya shillings. Then we check the activity which is to be crushed. We can now crush activity. We are moving in ascending order depending on the cost slope, but we must be along the critical path. Activity 1 to 2 is the one now we are going to crush. Activity 1 to 2 has got 2 days, which are 2 days are available for crushing. Normal time minus crush time, that is 2 days. So activity 1 to 2, activity 1 to 2, activity 1 to 2 has got a cost slope of 30 days. 60, that is what? 60, that is divided by 3, by 2. 30 days. Activity 1 to 2 has got 30 Kenya shillings per day. So when we crush activity 1 to 2, and there are 2 days which are available for crushing of activity 1 to 2. So this one becomes what? 10 minus 2, which is 8 now. So 8, because the activity is crushed, available 2 days now, the total cost is 6 Kenya shillings, 670,000 plus 2 days which are available for crushing times 30,000 Kenya shillings per day, which is, this is now 2 times 30, that is 60,000. 60,000. Then 60,000 plus that, we have 7 Kenya shillings, 730,000. 730,000 Kenya shillings when activity 1 to 2 is crushed. Now let us draw a network when the duration has changed to 8 from 10. Now when it is 8, we draw another network. 0 plus 8 is what? Is 8. 8 plus 6 is 14. 14 plus 6 is 20. 20 plus 4 is 24. 24 plus 5 is 29. 29 minus 5 is 24. Then 24 minus this 4 is 20. 20 minus 6 is 14. 14 minus 6 is 8. That means activity 1 to 2 has been crushed, and the total now cost, the total direct cost is now 700 Kenya shillings, 730,000. Then Now step number 5. We want to crush activity 3 to 4. We want to crush activity 3 to 4. Activity 3 to 4. Activity 3 to 4. Activity 3. Activity 3 to 4. Activity 3 to 4, it has got 3 to 4 has got how many days which are available for crushing? 1 day. 6 minus 5. Activity has got 1 day. When it has got 1 day for crushing, the total cost from here is 700. Total cost, total direct cost, total direct cost before crushing that activity is 730 plus its cost slope. It is having the highest cost slope, 40. Then 40,000 times 1 day which is available, 1 day which is available for crushing. Then this one becomes Kenya shillings 770,000. It becomes Kenya shillings 770,000. Then activity that 3 to 4. That activity we are going to crush it by 1 day. So this one now, another network is drawn. We're using now 5 days. 5 days. We construct another network. 14 plus 5 is 19. 19 plus 4 is 23. 23 plus 5 is 28. 28 minus 5 is 23. 23 minus 4 is 19. 19 minus 5 is 14. There is a pattern here which has developed. This is now the critical, this one is the critical path, plus another critical path has been developed. That is 5 to 4 is the same as this one here, which is 9. 5 plus 4 is what? 5 plus 4 is 9. And this is also 9. So, therefore, another critical path has been developed. So, there is another critical path, which is 1 to 2, 2 to 3, 2 to 3, that is 2 to 3, then 3 to 5, 3 to 5, then 5 to 6. So that is another critical path, because the length of this one here is the same when you get this approach. 5 plus 4 is 9, and this is also 9. So immediately a new critical path has been developed. There are now 2 critical paths, and therefore when we continue crushing this project, the duration of the project, the total duration will not change, and therefore the project has been crushed to its minimum duration of 28 days at a total cost of Kenya shillings 770,000 Kenya shillings. That is the amount. So viewers, we can stop there. then we'll continue with more examples, example 2. Thank you very much.